STUB. STUB means what? STUB, a STUB router, a STUB road. Just now I told my friend Arindram that I live in a dead-end road, which is a STUB. My house is in a STUB area. In a STUB area, meaning if I want to meet Arindram in Philippines, I need to go out of my road. If I want to go and meet our Rajshekhar in London, I need to again take the same road and go out of the road first. If I need to meet Mr. Gaurav, I need to take the same road again to go and meet him in US. So, in short, anywhere on earth, if I want to go, first I had to take that road, and that road is the only road I need to exit. I don't have any other road. That's the only road. Because my street is a STUB area. If in case this my house, not only have got one road where I can go to all of the rest of the world, in case if I have another road here, then if I want to go to airport, I'll go this way. If I want to go to city or bus stand or railway station, I'll go this way. Then this is not a STUB. My area cannot be called a STUB because some destinations have got different gateway than the other. But because I don't have any other road to my right, if I want to go to airport also, I need to go this way. If I need to go to London also, if I need to go to fish market, I need to go this way. If I want to go to church, I need to go this way. If I want to go to a vegetable market, I need to go to this way. That's the only way I can exit, only gateway for any destination. If you got only one gateway, then you can call a STUB router. Likewise, if you notice, between the areas, there is only one router as a ABR. There is only one router as a ABR between the areas. We got an area and we got some other area connected to that area. Yep. So all those networks inside this area, they have only one exit in order to reach any other area network. So every area is a STUB area. But STUB is not by default. STUB is not by default. Point to be noted. Unless you say this area is a STUB, unless you say that this area is a STUB, So we have to tell our area routers that you are in a stub area. Why should I tell? Why should I need to inform? For example, one midnight you landed in India and you decided to stay with me for a week or a month. One midnight you landed in India. I was driving from airport to our place. See, I had to inform you that in the morning, anything you want to buy, if I'm not around, you need to simply take this left-hand side road, keep going, and look for things that you want. If I don't mention it, you will be confused whether to take left or right because you are new to this place. If you go left, it's a dead end. Nothing will be there. Waste of walking. I should inform you that anything you want, which is not in this room that I have, you are staying. If I'm not around, you need to simply, go down, take left, keep walking. A lot of shops will be there. You can buy. I need to inform you. Otherwise, you may think like, I cannot buy because I may get lost. I'm not sure whether I should go left or right to buy this pizza. So you will stay at home. Maybe you will not get down from the home. Likewise, when an area is a stub area, it is good to inform the routers that you are a stub router. So you see, because I inform you that it's a stub road. This house in this area, we are in a stub area. Now I don't need to explain you. If you want to go to airport, go to this road only. If you want to go to market, take the same road. If you want to go to temple, take the same. I don't need to explain you those things. It's well understood when I say it's a stub road. No one needs to explain you. Go to that market, you need to take this road. And go to that street, it is the same road you need to take. You don't need to see, no one need to explain. If it is well said that, it's a stub road. You understand that any destination I need to take, I need to go, this is the only direction I need to walk. See? When I configure an area as a stub, what really happens is, instead of saying, in order to go to airport, go this way. In order to go to market, go this way. No need to say all these things. When an area is configured as a stub area, all the routers in that area will have a default route pointing towards the edge. A default route pointing towards the ABR. So that default route is more than enough for you to reach any area's network. Any network that are in other areas. So you can avoid learning routes of other area, but still you will be able to reach those area because you will be having a default route injected into you all of your router given by the ABR. ABR will generate a default route and provide a default route dynamically uh, dynamically installed into your routing table. Default route dynamically get installed into your routing table, and the default route will point towards the IP address of the ABR. So your routing table is much smaller now. You don't need to do summarization to achieve this. You don't need to do any manual route filtration. When I configure an area as a stub area, I can reduce the size of the routing table by having only the local network routes in the routing table. For all the other area network, I'll just have only one default route. See, we got a backbone area, you know why? That will have a detailed route information of every destination. When we have a default, when we have a backbone area, then why I should know as a member of area 1? Why should I know all the destination? All that I need to do is simply go to this ABR. ABR is connected to area 0. Area 0 knows about every destination, every single destination in this autonomous system. Some may be in area 2, some may be in area 3. Area 0 is going to have a very clear route information. As a result, I no need to know. I need to simply send it to area 0 member who is my ABR. That ABR will take care of forwarding the traffic to the destination which I want to go. So, you no need to learn the routes of other area. As a result, routing table is going to be small. If routing table is smaller, the time taken to figure out the route for the destinations for the packet forwarding will be less, process utilization is less, and the efficiency goes up higher and higher, so that you can add more and more network, which makes OSPF more scalable routing protocol. So you need to inform the area you are a stub. Only then the other than local area network, we can have a default route. So more about it is coming later. But before that, I want to tell you that you cannot configure area 0 as a stub area. You know the reason why, you know the reason. You know the reason. Why? Because you are going to make other areas a stub. If you make area 0 also as a stub, then who will direct the packet? No one will know about the other area networks. Area 0 need to know. Area 0 is like a certification authority, root certification authority, if you are from security world. It's not subordinate certification authority, root certification authority, root CA. Don't worry if you don't know about that. Simply saying, area 0 is an all-knowing person. You cannot configure area 0 as a stub area. Should not. All right. Now, sometime there are chances for you to have area here. We all know that every area should be connected to a backbone area so that the routes can get distributed from this area to other area. But poor area 4 members don't have any direct connection to area 0. For some reason, they got only one router nearby this router, which is a member of area 3. So this router is a member of area, no. This brown one is the member of area 3. And this router blue has got only option to connect to this brown router. There is no provision to connect like this. Maybe there is no lengthy cable. Or this router here may not have an additional port. There is no extra port. The ports of those routers are already occupied. There is no port for connection to be made here. There is no interface. So you got a port in this router brown, you connected to it. But the problem is, there should be a backbone area which is not present in between area 4 and area 3. Without backbone area, routes of area 3 won't be given to any other areas. Without backbone area, that's not possible. Likewise, area 1, area 2, area 3 routes will not come to area 4 because you don't have area 0. So connecting to a backbone area is must. The neighborship will come because this interface here is a member of area 4. Both the end it is area 4. Because the area ID matches, they form neighbor. And this port and this port is area 3. What did you ask? No, it will form full adjacency. It will form full adjacency, but the sharing of routes will be as per the rule, as per the norms. It will form full adjacency, but area 4 routes won't be given to area 3 interface. Say adjacency is between only these two routers. Likewise, this is another adjacency. The routes that are learned because of adjacency 1 will not be given to the adjacency 2 because in between what is needed is area 3. So, the solution for this is we can have a tunnel, a virtual link between these two routers. So this router is completely into area 3. End to end, you can have area 3 to provide you a virtual link so that this router will feel as if it is connected to backbone area 0. Via this virtual link 0, this router gets an opportunity to form adjacency with area 0 member. This is a member of area 0 also, no? ABR. Now what happens? The route update goes through the virtual tunnel to this router, area 0, and area 0 distributes back to other area. Virtual link is the OSPF feature that allows you to use the router IDs of this router and this router to negotiate a pipe, a tunnel. Using the router ID, you negotiate, not the physical address, not the IP address of this link or this link, not this port IP address. You need to know the router ID of this ABR and this router. This cannot be called as ABR because it's not connected to area 0, but we want it to become an ABR by forming a virtual link. So what you can do is you can go to the, for example, let's say the router ID of this router is 1.1.1.1. The router ID of this router is 7.7.7.7. The command goes like this. You need to go to this router and say, under OSPF, you need to say area 3. I'm typing A, means AREA. That's the spelling. Area 3 is a virtual link. You need to type virtual link fully. Link. And that virtual link is still 1.1.1.1. This is the address to which you need to. This is the router ID. This is the router with whom you need to negotiate. This address need not to be a pingable address. Repeating. This address need not to be a pingable address. It is just the router ID of the ABR. It's just the router ID of the ABR. The database here knows where is that 1.1.1.1. Likewise, you go to this router and say area 3 is a virtual link for 7.7.7.7 from this router. So both the side you have to configure. When you configure this correctly, you will find a new adjacency. You will see loading to full via virtual link 0. Now why I am teaching two topics in this class. The original topic is STUB. The reason why I am bringing this is you cannot make area 3 as a STUB area because this is not a STUB area, because this is acting as a transit for this area 4. You cannot configure area 3 as a STUB area because there is a virtual link going through that area. So we have learned two topics. We learned what is STUB area. The other topic is what is virtual link. Virtual link in OSPF helps to connect an area that is not really connected to backbone using an intermediate area as a link, virtual link. We don't have a real wire in between. We are making use of the existing area 3 to provide us the virtual connection, a tunnel, and encapsulation. Right. Now, I just gave you an introduction to STUB. This is not all about STUB. There are many more things to learn. Types of STUBs we have not focused so far. But before that, I have to teach you something which we didn't focus earlier. It should have been done earlier. Whenever you have a point-to-point router, let's say 192.168.1.0, sorry, 1.1/24, 192.168.1.2/24, and let's say the router ID is 1.1.1.1 because I got the IP address on the loopback interface. If I draw like this, a curved line, it is loopback interface. Okay, it's a standard notation. Okay, fine. Now, when I configure OSPF on this two router, what really happens? This router will send its hello packet. When it sends the hello packet, it will carry its own name, means the router ID. So router 1 sends hello packet without knowing that I am talking to router 2. It do not know the address of router 2. So it will use how? It will use 224.0.0.5 address, a multicast address, and say, this is me talking. If you have ears to hear me, know that I am here. My name is 1.1.1.1. Yep. So router 1 is shouting loud, telling, I'm here. My name is 1.1.1.1. Is anybody there? Please learn that I'm here. Okay, the router 2, it says, All right, so let me make a note. My dear friend, your name is 1.1.1.1, correct? Okay. It learns the neighbor's address. But before accepting that as a neighbor, before adding that router 1 router ID in the neighbor list, it will check certain parameters like area ID should match. Area ID should match. Next, subnet mask should match. Next, timer should match. Hello timers. So by looking a few more things, stub type, authentication type, let's not get into that now. So when these things matches on either side, sorry, when this thing matches with a local, R2 says, okay, because you have the same timer as I am, because you belong to the same subnet as I belong to, /24, because we both are in area 0 or area 1, whatever, same area, I accept you as my neighbor. So router 2 has learned a neighbor, but router 1, no neighbor yet. No neighbor yet. Now, router 2 gets a chance to say hello. Same multicast address 224.0.0.5. It is sending hello message saying router ID 2.2.2.2. Now, when the hello is sent, even the neighbor list is sent. Neighbor list is sent. 1.1.1.1. If there is more neighbor, all neighbor information will be sent. But in our case, there is only two router. Now, router 1 learns that there is a neighbor called 2.2.2.2 with the same timer, same area ID, same subnet mask. Surprisingly, he already know me. Wow, what a joy. He already know me, and now I know him, which means we both know each other. Wow. So, both the routers are now knowing each other. But what is not done so far is no sharing of any updates, link state advertisements. So far they have learned each other, that's all. I know this face. He is my opposite house neighbor. And he also knows my face. Other than that, we don't know anything. I didn't go and talk to him. He didn't come and talk to me. I know that face and that face knows me. We know each other only by face. That you may say that he's my neighbor, or he may say that I'm his neighbor, but doesn't mean that he knows what all I can do for him or what all he can do for me. Meaning the routers need to share their database. Only then the routing protocol's purpose will be met. Just two routers saying hi, hi, and farming neighbor. What for? What for? No use. Need to help each other. Unity is strength. Sharing update is very important. So this two routers so far has said hi, hi, that's all. Okay. What is next then? When are they going to share? My opposite neighbor, he did not want to talk to me because he is old man. And he thinks that, why should I go to the small boy and talk to him? Let him come. You see, unless this is fixed, they cannot form true neighborship. They cannot share things that they have got. They cannot help each other. As long as this attitude is there, these two guys are not going to be fruitful in their life. They're going to live a selfish life. This guy has got nothing to help him, and that guy also has got nothing to help him. You see? So, they need to come to an agreement. So this old guy, you see, old, 2 dot 2 dot 2 dot 2. See this one? 1 dot 1 dot 1 dot 1, younger guy. They live opposite house, opposite, facing each other. They know their faces. As a neighbor, they know each other. But they've never shared any advertisement so far between them. The problem is the stubborn nature of R2. I am older one. Let him come and talk to me. And this R1, oh, he's an old person. If I go and talk, will that be a disturbance for him? Will he accept me? He's got a big mustache. He always stares at people. Oh, should I go and talk to him? Will he talk to me? What if he don't talk to me? Then it will be a shame for me. So, both are not going to be helping each other. Even if fifth wave comes, they're going to die separately. They're not going to live as a human being. What is the solution? They need to learn from OSPF. The solution need to be learned from OSPF. What is the solution OSPF has got? R2 will say, hey, I saw your hello packet. You are much younger than me. Which means I am the oldest. So let me initiate the sharing of my database with you. Let me share, in short, my life experience, my life story with you. In short, DBD, database description. Let me explain you who I am. So R2, being an older person, a senior matured person, says, I'll initiate. And R2 sends the DBD. R2 decides. R1 agrees. R2 decides to be what? Master. R1 agrees to be what? Slave. Just for time being, okay? This master slave is not forever. For time being. Initially, only this is initial stage. I know that face, he know my face. We live opposite. Now, as a young guy, I should be submissive. I should be a slave kind of mental person, status, slave kind of. My building may be bigger than his building, but I have to give respect to his age, his experience in his life, if I want to learn from him. So I should go with a slave mentality, and he will be in the master mindset. Only then the true learning will happen for me. If I also try to be master And he also tries to be master. Oh no, no one is going to learn from anyone. So, you see, you have to learn from OSPF. This is very beautiful. To win the world, this is the secret. Those who want to become a master first learn to be a slave. Bible teaches. If you cannot be a slave, you cannot become a master. Simple but very deep knowledge. Wisdom. This is wisdom. That is what exactly you see in OSPF, you see. Router 2 says, hey, I am the master. And router 1 should agree, yes, sir, we are slaves. Only after this agreement, master sends the DBD first. And an acknowledgement with the DBD, we call it as LSA, link state ACK, with DBD will be sent by the slave to the master back. And followed by acknowledgement from the master. Link state acknowledgement, LSAC. And now these two are going to be unicast. Now what has been shared is only DBD. It's not a detailed one. It is not a detailed one. It's a database description. They share each other their experience. Hey, you are talking about that Hong Kong to Shanghai to Hong Kong flight experience. Can you brief me? Can you explain me more about it? What really happened? You said something like they didn't even give you water to drink from Shanghai to Hong Kong? Is that Malaysia Airlines? What really happened? He wants to know more information, which we call it as link state request. So link state request will be sent by both. It's a query that they both send for clarification to know much better. So DBD is not that detailed, no? It's a summary. So LSR is sent. For LSR, there is a LSU sent. Link state update sent. After a point of time, there is no query to ask. They have fully learned about each other very well. They know each other very well now. So they're fully, either side, identical database. They have fully identical database. Within an area, I told you the database will be identical. They got fully synchronized database now. Now, this is what we call it as OSPF adjacency. You know this one, R1 is sending hello first time. It becomes an init state here, initialization state, init state. And when R2 was sending hello, R2 was carrying R1's router ID in the neighbor list, which R1 is now looking into, and R1 knows that R2 already know about me. That we call as two-way state. That state, that the relationship status between these two routers is right now in two-way state. I know you. You also know me. It's two-way state. And now this older person says, I will be the master. I'll initiate everything. And the other guy agrees, yes, 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 yes. We are slaves. This agreement, we call it as exchange start. That's the beginning to start. That is the beginning to start knowing each other. If this is not made, if I say I go all around the world, I have delivered trainings in almost 12 countries, more than 20 foreign visits. This man, though he may be old, but he may be a lawyer or whoever, whatever, retired from, he cannot be that big for like me. If I have that master attitude, no exchange is going to start. So one should be a slave so that he can tomorrow be a master. So when that agreement happens between these two routers, we call it as X start state. There's going to be a exchange start. And then what happens? Exchange state comes. X start state. Exchange is happening. Exchange of DBD is happening. And then they got some queries, right, to fix. We call it as loading state. They are loading each other. They're knowing themselves better. They're learning each other better. After some time, they are fully synchronized. They reach full state. This is unicast. This is unicast. Only initially, no, you have the multicast. If two-way is multicast, init state is multicast, all the rest are here unicast. And what we are seeing is a point-to-point link connect. In point-to-point link, there will not be a designated router or backup designated router. We all know that. So as a replacement for DR and BDR, you have master and slave. Now, once the sharing has happened after reaching full state, there is no more master slave. Both are good friends now. No differentiation. Both are equal. Both feel both love each other as they love themselves. And they started helping each other. 5th corona wave came, they survived. 10th corona wave came, they survived. They lived happily for a long time. The end of OSPF adjacency when you have a serial wire. Now, what if I have an Ethernet wire? There will be init state, there will be two-way state as usual. You may be having more routers, and let's say the router ID is 3.3.3.3, 2.2.2.2. Now they all have reached two-way state, and all the router knows the other router's router ID, and router 3 will say, hey, I'm a BDR. Router 3 will say in the extat state, I'm a BDR. After some time, it will say, see, I don't see anyone bigger than me. So I'm worthy, I'm eligible to become a DR. And now R2 will say, aha, if you are a DR, then I will be a BDR. Because I am eligible. R1 is only 1.1.1.1. My router ID is 2.2.2.2. So I am BDR. R2 says. So this is the only difference. In the extat state, there is going to be a DR and BDR. And you know very well, DR will initiate the sharing of DBD, and all BDR will share only to the DR, and DR will share it to all the rest of the other routers. The other routers will share it to DR and BDR. Sorry. The other routers will share the updates to DR and BDR using 224.0.0.6 multicast address. Multicast address is used here. And DR will receive it and use 224.0.0.5 to distribute the route of advertisements, the LSAs, the DBDs. Using 5, it will talk to the other routers. So that is how the exchange happens using multicast address. This is not a point-to-point. So you will not have a unicast. You will see multicast. Exchange of DBD. And then, as usual, there will be some queries, LSR, and then LSU, which is called as loading state. And then, after a point of time, all the routers are synchronized in the database. They reach full state. The end. Question, please. OSPF adjacency. Completed. Any question? No questions? Fine, then if no other questions, we'll meet again and we'll continue this lab first. We'll see the adjacency state. I'll capture some packet and show you. Then we'll do virtual lab, virtual link lab, followed by the STUB types. And then authentication in OSPF. Thanks for joining. Have a wonderful evening, wonderful day. Bye-bye. Welcome. Welcome.